Hello everyone. This is multifaceted extortion analysis of data exfiltration TTPs used by ransomware threat actors. A brief introduction about myself. I am Kunal Shandil, working as a senior consultant with incident response and forensics with CrowdStrike professional services team. Formerly, I was with Trustwave Spiral Labs working in a similar role. And in the last 5 years, I have gained a bit of experience on incident response, digital forensics, and threat hunting. So the agenda of today's talk is about double extortion aspects in recent ransomware incidents. What are the different phases of data exfiltration and what are the tools used by threat actors to achieve their objectives? During the talk, we will also try to identify what are the different log sources these tools generate when they are operated by the threat actors and how, as a blue teamer or an incident responder, we can analyze these log sources to identify what are the actions performed by the threat actors during data exfiltration. We have lots of different artifacts to cover, so let's get started. So the first reported ransomware incident was reported back in December 1989 when an insurance company in Belgium was targeted for a ransom of $189. In that particular case, the encryptor was delivered through a computer floppy disk. And we all know that the ransomware economy have grown over the years. So the first double extortion incident was reported in late 2019 when threat actor group Maze not only encrypted the environment, but they also exfiltrated the data from the environment. The data clearly suggests that the percentage of ransomware attacks which involves the threat to leak exfiltrated data has grown over the years. And for using and for exfiltrating the data, the threat actors use multiple different types of software, third-party tools, which we will be covering during this talk. MITRE ATT&CK frameworks talks about 9 different exfiltration techniques to exfiltrate the data out of the environment. However, in this particular talk, we will be covering only on the exfiltration that happens over web services, because this is one of the easiest technique that are used by the threat actors to exfiltrate the data. Most of the time, the outbound 443 ports are open in the environment, and threat actor leverages that to exfiltrate the data. In the last few years, I have experienced multiple different data exfiltration tools used by the threat actors. And in this particular talk, we will be covering most of them. To understand the data exfiltration process, first we have to understand how a typical ransomware incident looks like. So a typical ransomware incident starts with threat actor performing some sort of reconnaissance for the victim organization. The threat actors are trying to identify what are the exposed services which does not have multi-factor authentication enabled in them, what are the different unpatched vulnerabilities in the client's environment, and what are the different ways they can make an initial entry point in the infrastructure. Once they have gained the initial access, the threat actor will start and might install some sort of malware to create persistence in the environment. Once they have the persistence in the environment, threat actor will move next to compromise the domain credentials so that they can get hold of privileged credentials. Once they have privileged credentials, they can move laterally into the environment to identify the environment and understand more about the environment. In the next phase, the threat actor will exfiltrate the data before deploying the ransomware in the environment. We can categorize data exfiltration phase into 3 subphases, which I would like to discuss next. In these phases, we can divide this segment in data discovery phase, the data staging phase, and data exfiltration phase. In the first phase, that is data discovery, the threat actor will identify the critical systems which host confidential information for the customer. Once they have done that, they will move to the next stage, that is data staging, in which the threat actor will collect the data in a central location just prior to the exfiltration. Once they have achieved success in the phase 2, that is data staging, the threat actor will use multiple different third-party tools to exfiltrate the data out of the environment. In this particular talk, we will be covering all of these tools, and we will be discussing what are the different disk artifacts or memory artifacts these tools create, which can be analyzed by the blue teamers or incident responders. So let's first start with the first phase, that is data discovery phase. What exactly is data discovery phase? In data discovery phase, the threat actor will perform a post-compromise information gathering activity where they will try to identify the critical servers and confidential information stored on them. During this phase, the threat actor will use multiple different scanning tools and native operating system tools to identify this information. During this process, threat actor will make several network connections, which will be mostly SMB traffic to these servers while they are browsing those folders to identify the critical information. In the next few slides, I will be covering what are the different Windows forensic artifacts that will be generated when threat actors perform data discovery phase. So the first Windows forensic artifact, which I would like to share, is Windows shellbags. So shellbags are a Windows settings that tracks view preferences of folders for a user. So whenever a user views, resizes, or positions a folder through Windows Explorer, shellbag stores that particular information. This information is stored mainly under two Windows user registry high, that is anti-user.dat and user-class.dat. And shellbags stores the name and the path of the folders that were browsed by the compromised user account or threat actor, and the first and the last interaction time. This helps us to build a timeline of events of what folders a compromised user account has browsed during the time of interest. Similar information can be identified through another Windows artifact, which is the next one, that is jump list and shortcut files. So what exactly are jump lists? Jump lists are a Windows features that allows a user to jump or quickly access the items they frequently use. Jump lists are enabled by default since Windows 7, and they tracks historical user activity of files and folders that are accessed by a user over local machine, network drives, and on removable drives. There are two types of jump lists which are created on a Windows system. The first one is the automatic destination jump list, which are created by the Windows API and which we will be focusing for this particular talk. And the second one is the custom destination jump list. So jump list tracks the name and the path of the files that are accessed by the compromised user account, along with different MAC timestamps and the server hardware address. Both shellbags and jump list provides us the network drive letter name of the MAC destination server. So if you follow the screenshot, we can identify that the threat actor accessed the map network drive letter Y and accessed different folders, which looks important for the victim organization. The host name and the IP addresses of the server where these network shares are located can be identified through another Windows artifact, which I would like to discuss next. It's called Windows registries. So Windows registries are a hierarchical database that stores low-level settings for a Microsoft Windows. There are multiple different Windows registry keys, which we can analyze to identify the different map network drives that were created on the system. Most of this information are stored under user registry hive, that is anti-user.dat and user-class.dat. And once we have identified the server details, we can identify what files and shares that are potentially at risk from where the data might have been exfiltrated by the threat actor. In this particular scenario, I have used Windows registry for map network drive MRU to identify that the network share drive letter Y, which we identified in jump list and shellbags, belongs to the domain controller of the environment. Till now, we have discussed the forensic artifacts which are generated on the client systems. The next forensic artifact which I would like to share is generated on the server side and can provide us more context on the data discovery phase. So the next artifact is Windows User Access Logging or UL logs. So UL is a service that collects client usage data by server roles and by software products installed on the Windows Server. These are enabled by default since Windows Server 2012 and can provide us vital information about the past inbound SMB connections. So UL logs can help us to identify what are the different client systems that connected to that particular server during the time of interest. UL log tracks what are the names of the services, what are the different IP addresses which connected to that service, and the total number of accesses, along with the first and the last date of user activity. When we are analyzing UL logs, we can identify the total number of access for a particular system, and then it can give us a good indication that whether threat actor browsed multiple folders during data discovery phase. Once data discovery phase is over, the threat actor will move to the next phase of the attack, which is data staging. In data staging phase, the threat actor will collect all the identified information in a central location just prior to the exfiltration. Why threat actors perform data staging? They perform this particular phase to minimize the number of outbound connections and to avoid detection. So data staging analysis can help us to identify what are the contents of the exfiltrated files and what are their worth for an organization. During this particular task, threat actor can use multiple different third-party compression softwares or Windows native compression tools, which can help them to stage the data and exfiltrate it. So let's discuss about what are the different compression tools which threat actors uses in such incidents. So there are multiple different compression tools. For example, Windows, WinRAR, and 7-zip. And there are multiple Windows registry entries that are created whenever threat actors use them. I'll quickly briefly cover these artifacts, which can help us to identify what exactly has happened during the time of interest. Most of these artifacts for third-party compression tools are created under Windows User Registry Hive, that is ntuser.dat, and they contain similar sort of information like the history of archived destinations, the history of extracted destinations, and the list of accessed archives. Apart from third-party compression tools, threat actors also use native Windows tools which can be used for compression. One of the most popular tool is makecap.exe, which can be used to compress the target file into a cap file stored in the alternate data stream. To track or identify the usage of makecap.exe, we can leverage the different Windows artifacts, just like Windows Event ID 4688 and other program execution artifacts like prefetch, shimcache, and amcache. There are multiple different NTFS system artifacts that are generated when threat actors are performing data staging phase. Let's discuss a few of them. So the first one which I would like to discuss is the master file table records. So MFT records contain a record of every file and folder that is created on an NTFS volume. So during the staging phase, if threat actor creates any file or a folder on a particular NTFS volume, even if the file has been deleted by threat actor, MFT will have those records. Once we identify the staging directory path, we can identify the name and the size of the files that are potentially exfiltrated by the threat actor. However, in some cases, MFT records for a particular file can be overwritten. And in that particular scenario, we can leverage on another NTFS artifact, which is US in general. So what are US in general? What are USN general records? So USN general records are the transaction records that tracks the change of each file and folder along with their directory and with the reason that happens on an NTFS volume. So whenever a file or a folder is created, modified, renamed, or moved, USN general will track those changes. As a blue teamer, what we can identify from USN general is what are the different files that were stored on a staging directory and what exactly has happened after the data has been exfiltrated. Because if the threat actor is removing those files, USN general will track those changes. We can analyze same USN events and it can help us to create a timeline around the action of events performed by the threat actors. In this particular screenshot, we can see that the threat actor created few folders and copied over few files and on that particular staging directory. After the data staging is complete, the threat actor will proceed to the next phase, which is data exfiltration. In this particular phase, the threat actor will start moving the data out of the environment. And in that particular process, they use multiple different techniques. In this particular talk, we will be covering only on the cloud systems where the threat actor will try to upload the exfiltrated data. And in the next few slides, I will be discussing about the different windows and the third-party application logs which will be created during this process. So the first Windows artifact which I would like to discuss and which is one of my favorite one is System Resource Utilization Monitor Logs or SRUM logs. So SRUM is a part of a Windows Diagnostic Policy Service that tracks applications, service, and network statistics over time. SRUM logs tracks the application resource usage and the network connection and its usage. So whenever we open Windows Task Manager, go to the application history tab, and we can see a lot of data there. So all of this data is populated by SRUM, and it can give us a better understanding of exactly what has happened on that particular system during the time of interest. SRUM collects information every hour for each application that is running on the system. And this particular information is first stored in a Windows registry before it's being written on the disk. So SRUM tracks the name and the path of the application or service along with its date of execution, the user which executed the service, and it stores the most important information, that is the number of bytes uploaded and downloaded by that application. This can be very critical for the organizations which do not have network layer visibility. For example, if they do not have any flow logs or firewall logs available during the time of interest, some logs can help blue teamers or incident responders to identify how much data has been exfiltrated using that particular service or application. During testing, I used 3 different softwares to exfiltrate data from my lab environment. And in that particular case, SRUM was able to successfully log all these 3 attempts. So if you follow the screenshot, I've used MegaSync.exe, a renamed version of rlcone, and Megatools. And in all of those cases, SRUM was able to log on that 4.8 GBs of data was exfiltrated by using these 3 softwares. So let's focus on these third-party softwares which threat actors use and which we can analyze to identify what exactly has happened. I'll start with the first one, that is MegaSync. And MegaSync is a file transfer tool used to sync folders on a local system to the Mega Cloud Drive. Logging of MegaSync is enabled by default, and these logs are specific to the user that has installed MegaSync on the system. MegaSync log files track multiple information, which can be very critical from investigation point of view. And this particular log file tracks the local sync directory, the email account, which was used by the threat actor to register the Mega account, and the remote IP address along with the name and the path of the uploaded files. Identifying Mega's local sync folder is very important when we are investigating cases where MegaSync was involved. Because once we have identified the local sync folder, we can leverage on other Windows artifacts like shellbacks and NTFS artifacts to identify what are the possible exfiltrated files from the environment. However, there is a catch. So once MegaSync is uninstalled, all of these log files will be deleted. However, we can leverage on a keyword search trick of unallocated disk space to identify the same information. In this particular trick, what we can do is we can create a full forensic image of the system. And once we have that information with us, we can create different keyword searches for the data. This keyword searches can help us to identify what are the files that were exfiltrated by MegaSync. There is a caveat here. If the disk block or the cluster is overwritten, we will not be able to identify this information. The next tool which I would like to discuss and which is very popular among threat actors is rlcone. So rlcone is a very versatile tool which can be used to upload data for 40 different cloud storage products. Many times, threat actors will try to obfuscate rlcone by renaming it or by doing a timestamping of the binary. We can identify timestamping by analyzing the different timestamps from MFT records, and it can help us to identify whether the rlcone was executed on the system. By default, the logging is disabled on rlcone. So whenever a user executes rlcone, there will be no logs that will be generated on the system. However, we can leverage on another Windows forensic artifacts like Windows Event ID 4688 or program execution artifacts to identify if rlcone was executed on the system. Again, identifying this local staging directory in rlcone cases is very vital because once we have identified the local staging directory, we can utilize Windows NTFS forensic artifacts to perform a memory analysis to identify the name of the files that were exfiltrated. I would like to discuss about a memory forensic hack which we can use to identify the name of the files which are exfiltrated through rlcone. In this particular hack, what we can do is first we have to create a memory image of the system of interest. So once we have the memory image of the system, we can utilize sysinternal's string utility to extract all the ASCII characters and the Unicode characters from that memory sample. Once we have that information, we can extract the matching local upload directory path, which we have identified in event ID 4688. And in the last step, we can utilize Volatility's string plugin that can help us to locate the process memory segments where these strings are residing. Once we have done that we can get hits on the memory segment, mainly from the free memory, as rlcone has already exited. This particular information should be treated with a medium to low confidence because we are not 100% sure whether this particular files were exfiltrated using rlcone. Another tool which is popular among threat actors and which I would like to discuss is FileZilla. So FileZilla is a cross-platform FTP application which is used by threat actors to exfiltrate the data from the environment. There are two types of log which FileZilla generates. The first one is the screen log, which is visible on the FileZilla GUI, and it lasts for the sessions only. So once a user closes FileZilla, all of these logs will be purged. And the second one is the log file, which is unfortunately disabled by default. However, there are few configuration files that are generated by FileZilla whenever a user executes it. And in this particular configuration files, there are information like the IP address which was used by the threat actor to upload the data, and the remote and the local path, which was configured by the threat actor when they were uploading files using FileZilla. Again, we can leverage the local path value with the potential artifacts from shellback and NTFS artifacts, which we already discussed, to narrow down the specific files and folders that are potentially being exfiltrated using FileZilla. Apart from FileZilla, threat actors also use another tool, which is WinSCP. WinSCP is a popular free and open source tool used for file transfer and can be used for lateral movements as well. There are two types of log which WinSCP generates, and unfortunately, both of them are disabled by default. However, there are few configuration files which are generated whenever WinSCP is executed on a system. These are stored either on the registries or in a separate INI file. Whenever these configuration files are stored under registry, we can identify multiple information like the remote IP address and the remote directory and local directory. However, this particular information can be not used because many times I have experienced that the threat actors use the INI option, that is create another separate INI file just to maintain their operational security. Because the threat actors do not want these artifacts to be written on the disk, they will create a separate INI file, which they will be using while doing the uploads through WinSCP. And in many cases, where I have experienced that during the operation, threat actors forget to delete these INI files. The location of these INI files will be the same directory from where WinSCP was executed, and investigators can analyze these INI files to identify the different information like the local directory name, the remote directory name, along with the IP address. Several times the threat actor will save the session, that is, they will try to save the workspace, and once they save the workspace, we can get more information from the INI files. This could be the password and the uploaded bytes. So with this information, we can identify what are the different, what was the total bytes that were uploaded by the threat actors using WinSCP. The last tool which I would like to discuss is Megatools. So Megatools is another tool which is used by the threat actors, and it's a command line tool to exfiltrate the data to Mega Cloud. It's not a very popular tool amongst threat actors, but to operate this particular tool, the threat actor has to create a config file that contains Mega credentials in clear text format. At the time of the execution, Megatools creates a cache file under C users app data local temp directory. And if we got hold of this INI file, which the threat actors used, we can dump this particular cache file and get a lot of critical information from it. We can identify what are the different names of the file that were uploaded along with the timestamps. The last evidence source which I would like to discuss is Windows event logs. So there are multiple event logs that are generated during the 3 different phases of data exfiltration, which we already discussed. And Windows event logs are the primary source of evidence for any investigator. Please note that not all of these window event logs are enabled by default. For example, event ID 4688, which we leveraged a lot for the last few discussion artifacts which we discussed. By default, the command line process creation events are not enabled for this particular event ID. We need to review our Windows logging policy just to make sure that event ID 4688 logs command line for every execution of the process, as it provides a very good visibility for the blue teamers and incident responders. So let's quickly summarize what we have discussed so far. We discussed what are the different data exfiltration aspects of, of for the latest ransomware attacks, and what are the different phases of data exfiltration, that is data discovery, staging, and exfiltration. We also discussed what are the different artifacts that are generated on Windows and the application-specific logs which blue teamers and incident responders can use to identify the different files that were exfiltrated through the environment.